Alright, this is lesson 49, absolute value equations and inequalities. The objective students will solve single variable absolute value equations and inequalities. This is a lesson that Miss Good taught us, so I'm just going to go quickly to get the main points across in case you needed help. But if you need more help, please come on in and make sure you ask for it for myself or Miss Good. So the definition, write this down if you're on the video, but the absolute value of a number is the distance from 0 on the number line. So we write absolute value of x, which is this right here, to represent the absolute value of x, which means how far is x from 0. Here are some properties you want to write down. The absolute value is always positive. That's what this means over here. This one means that we could take the absolute value of two numbers being multiplied and we could separate them as two absolute values being multiplied together. So there's a little imaginary multiply sign there. And the last one, when we have the absolute value of a negative number, means that it is going to be equal to the absolute value of a positive number. Okay, take a moment to write that down. Here are the steps for today. Pause the video here if you want to write down the steps. Big idea: we have to isolate the absolute value sign, then create one equation or inequality for when what's inside the absolute value is positive, and then the other one for what is negative, and then you solve each equation or inequality. So here's an example, a simple example. Number one, absolute value of x is equal to 7. So we're asking ourselves, how many ways can x be, or can you be 7 units away from 0? So we first want to make sure we isolate the absolute value on one side of the equation. It already is. So we make two equations. Absolute value of x could be x is equal to 7. And the second way I could look at as the negative x is equal to 7. Divide both sides by negative 1 or multiply by negative 1. And we figure out x is equal to negative 7. So there's two answers when we deal with absolute value signs. Last thing we need to do is graph these. So you would plot these as points on your number line. So we have a 7. We're going to draw a circle and we're filling it in because it's included in our solution, and negative 7. And that's the basic idea. Let's try another one. I'm going to keep moving. Let's do a more difficult one. Let's do this one on the left here. Absolute value of 3b plus 2 is equal to 7. Same concept again. We have an absolute value sign that is isolated on one side of the equation. You can see the equal signs right here. So we want to, since it's already there, we can rewrite this equation as two separate equations. We got the absolute value of 3b plus 2 is equal to 7. And then the second example is 3b. Our second equation is 3b plus 2. But we want the negative version of that, so we're going to put a negative sign with parentheses is equal to 7. So whenever you deal with quantities, make sure that you keep parentheses around the quantity. So this first one's positive, second one's negative. Now we're going to solve for this first one here. We need to subtract 2 on both sides, so we're going to have 3b is equal to 5. Divide both sides by 3, you get b is equal to 5/3. So that's your first solution to this absolute value equation. Second solution, we have this negative sign, so we need to divide both sides by the negative sign, or negative 1. So we have 3b plus 2 is equal to negative 7. We're going to subtract 2 again. So we got 3b is equal to negative 9. Divide both sides by 3. So b is equal to negative 3. Here are our two solutions, 5/3 and negative 3. And we would graph these on a number line when present. The next example here on the right is a little bit more difficult because we have 3 as a coefficient of our absolute value sign, and we have to subtract 5. So we have to think about isolating the absolute value sign. So we're going to have to use backwards orders of operations using SADMAP. So we have to ask ourselves, are there any things being subtracted? There are. This is minus 5, so we're going to add 5 to both sides. You got the 3 times the absolute value of 4w minus 1 is equal to 15. We still got this 3 on the outside as our coefficient. We divide both sides by that 3, so we got the absolute value of 4w minus 1 is equal to 5. And we need to, since we have the absolute values already isolated on one side of the equation, we're going to make two equations, starting with the positive absolute value, putting that into its parentheses. This one will have to be positive, it's equal to 5. Second one, we're going to make negative absolute value of 4w minus 1 is equal to 5. Okay. On this first one, I'm going to just add 1 to both sides since it's already positive and we have this negative 1, so it's going to be 4w, we're adding 1. Divide both sides by 4, you get w is equal to 6/4, and we could simplify that to be 3/2. Second solution, divide both sides by a negative sign, so we got 4w minus 1. It stays in its parentheses, but we're going to move that, change that negative and keep it as a positive. But this 5 needs to change to a negative 5 because we're dividing both sides by a negative 1. Add 1 to both sides, you get 4w is equal to negative 4, so therefore w is equal to negative 1. So that's the basic concept of how to solve absolute value equations when we have a single variable. You're always supposed to check your work. In this case, we only don't have a variable on the right side of the equation. We just have a whole number. So if we were to plug these back in, you'd still get a checkpoint that'll say 10 is equal to 10 on this example for both of these. So, but usually it's a good idea for you to check your work. Okay, moving on. I'm going to skip over to our inequalities now. But if you wanted to practice, here are some more examples that were supposed to be in your notes. Here's some more examples. Here we go. Examples of absolute value inequalities. So this one actually looks a little weird because we have this absolute value x is greater than 3. So I'm going to just erase that and I'm going to move it over here. Absolute value of x is greater than negative 3. Okay, so we got two examples here. So same thing as last time. We want to make sure that we have the absolute value is isolated on one side of the inequality. So we do. So we're going to just copy the positive absolute value and keep the sign the same as the term on the opposite side, or terms on the opposite side. So x is less than 3. X is already isolated, so this is our first inequality. This is our first part of our solution. Then we have to be very careful when we write the second equation. We take what's inside the absolute value, which is just x in this case, and we're going to make whatever's inside that absolute value a negative. And then we have to switch our inequality sign. In this case, it's less than. We have to make it greater than. Okay, now we have to solve. Oh no, we don't do that. Actually, that was a bad habit. We make it less than. We're going to switch it in a moment here. Then we have to isolate this x right here, dividing both sides by negative 1. And if you remember, when we divide by negative, then we switch the absolute value sign from a less than to a greater than. So take note of this. We get x is greater than negative 3. Okay? Then we need to graph our solutions. So from Algebra 1, you should remember to draw a circle around the points where you're going to have the solution. So in this case, the first one is x is less than 3. Since it doesn't include the equal sign in its solution, for instance, it doesn't look like that, it doesn't really include 3. It's saying it's less than 3. So we're going to leave the circle open. We're not going to fill it in like this. If it included the equal sign, we'd leave it like that, but we're not going to leave it like that. Then we're saying it's less than. So we know that the arrow should go left, but we're going to leave that alone for now. Looking at the other solution, negative 3. We have a negative 3 right here. Again, there's no equal sign, and this one's saying it's greater than, so we know the arrow's going to go right. So we're going to leave it as an open circle, not filled, and we're going to draw a line between the 2 points. And what we're saying here is that any solution between negative 3 and 3, but not including them, would be included as solutions that would make this equation true. Okay, so on the second one, it actually should be positive 3. Absolute value of x is greater than 3. You could practice that. You'll notice, though, as your solution, I won't work this all out, but you're going to have a similar solution where you have 3 and negative 3 circled, they won't be filled, but instead of the line going in the middle of the two, you're going to have two separate lines. One will be going outward, and one will be going to the left, and one will be going to the right, to infinity. And what that means is that we could use any solution on the outside of 3 and negative 3, but not equal to them, and not in between the two, such as this area, and they would make this equation true. So try that one by yourself, see if you can get that, but that is your solution. Okay, I'll do one more example here for the sake of the video. So just like last time, we want to isolate the absolute value sign. So I'm going to focus really on this one on the right here. So I'll erase the one on the left. You can practice that one on your own or get the notes from someone else. Okay, so for this last example, we want to make sure we isolate the absolute value sign first. So we have to locate it first. So we have 3 times this absolute value sign of 2x plus 6. This is all in its own little parenthesis. All minus 9. So we could clearly see that it's not isolated right now. So we need to isolate it first. Okay, so using backwards orders of operations, I'm going to have to add 9 first. So we have 3 times the absolute value of 2x plus 6 is less than, we got to do 15 plus 9, which is 24. Then we have to divide both sides by this positive 3. Since we're dividing by positive 3, we're going to leave that inequality the same. We got 2x plus 6 is going to be less than or equal to 8. Okay, now we have the absolute value sign. It is isolated, so we're going to make 2 equations. One's going to be positive, one's going to be negative. So we got 2x plus 6, all in its own parentheses, and this one's positive, so we're just going to leave it alone. It's going to be less than or equal to 8. Then we're going to do this one more time. We got 2x plus 6, but we're going to make this one negative, is less than or equal to 8. Okay? Then we're going to solve each of these. This first one, we just have to subtract 6. So we got 2x is less than or equal to 8 minus 6 is 2. Divide both sides by 2. We got x is less than or equal to 1. So that's our first solution here. The second one, we're going to divide both sides by a negative sign. Since we're dividing by negative 1, this is like saying negative 1. We want to flip the sign, so it's going to be not less than or equal to, but greater than or equal to. And it's going to be now negative 8. Then we're going to subtract 8 on both sides. We've got negative 8. Negative 8 minus 6 is negative 14, so we got 2x is greater than or equal to negative 14. So x is greater than or equal to negative 7. You would graph these on a number line, but these would include a filled circle, and you'll notice that they'll connect. So these are just some quick examples. I want to make sure you had a video for this. If you have more questions, make sure you come to class. Come talk to me, okay? Have a good day.